Hello! You join me in the Worgan household as we prepare for Christmas. My latest confection, a nice cherry glazed ham, ready for my mum and dad and family to have a buffet later on. But in making that, I've made rather a mess of this roasting dish. Look inside that, it is disgusting. It's all the grease from the ham, it really puts you off, but at least it's been cooked out, we're not going to be eating it. And all the burnt bits and things. The grease I can do something with. I can mix it with various seeds and things and turn it into bird food, but I'm a little bit in the doghouse because I really have burnt these bits of ham onto the inside of the roasting tray, and normal soap and water just won't get them out. Fortunately, we live in a chemistry household, and so I've got some nice cheap oven cleaner. Here it is. Solid sodium hydroxide pellets. Really nasty stuff if you don't know what you're doing with it, and I really don't recommend that you make your own oven cleaner solutions unless you know what you're doing. However, I do, roughly speaking, know what I'm doing. The only problem I've got is turning these solid pellets into something that will make a nice solution that will dissolve this grease. And for that, I need to work out the safe but powerful enough concentration of sodium hydroxide in order to make a solution of it to make my oven cleaner. And that is the point of this video.
Okay, so what is concentration? A solution is a mixture made of one chemical compound called the solute, dissolved into another chemical compound called the solvent. The concentration of the solution is a measure of how much solute we have added to our solvent. If we keep the volume of solvent the same, then the greater the mass of the solute we add, the greater the concentration of the solution at the end. I've got 3 glasses here with an identical volume of water, 250 centimetres cubed. In the first glass, I will add 10 grams of table salt, which is sodium chloride mostly. In the second glass, I add 20 grams of salt, and in the third, I will add 40 grams of table salt. Which of these solutions, 1, 2 or 3, will taste the most salty? Solution 3, of course. They all taste disgusting, but glass 3 tastes the most salty and the most disgusting. Concentration is an important concept in science. Lots of topics, but for example today I'm going to talk about cooking.
In cooking, for example, one tiny grain of salt is going to do nothing with regards to the flavour of this delicious meal, whereas if I tipped the entire contents of this salt pot over this, I'd have ruined our family New Year's Day dinner.
Similarly, farmers may wish to fertilise their fields, but too little fertiliser won't be any use at all to help the plants grow, and too much will either be a waste of money or, even worse, harm or even kill the plants they're trying to grow. If I make my cleaning agent too dilute, it won't do anything. If I make it too strong, it could melt not only the grease in my food, but also the non-stick coating from my tin, and any cleaner left on the tin afterwards could make the next thing I cook in it too dangerous for my family to eat. Never mind my own poor cooking skills. The units of concentration are either grams per decimetre cubed or moles per decimetre cubed. 1 decimetre cubed is also the same volume as a litre, which is also 1,000 centimetres cubed. It's annoying that there are so many different units and names for measurements going on, but we have to get used to them. A lot of beakers in the lab and jugs in the kitchen also list volumes as millilitres. Millilitres and centimetres cubed are exactly the same thing. It's all very frustrating. Later on, you're going to need to practice converting decimetres cubed into centimetres cubed and back again, and also learn how to calculate the concentration of a solution, even if the volume of it is greater or less than 1 litre, or 1 decimetre cubed. For now though, let's go back to making some homemade pan cleaner before my past cooking efforts get me into even more trouble.
Now, Sodium hydroxide has the chemical formula NaOH. One atom of sodium to one atom of oxygen and one atom of hydrogen. And I need that information in order to be able to work out a nice molar solution for my oven cleaner. I've decided to go with 2 moles of sodium hydroxide. I've used that before and it works really well. At the same time, if I accidentally spilled it on myself, it wouldn't be too bad. I'd be able to wash it off quickly before anything nasty happened to me. The only thing is, my other chemistry cup, which has a periodic table of elements on it, doesn't have the right numbers. It's only got the atomic number, not the atomic mass. So I need to find a periodic table of elements in order to be able to work out the right mass to use in order to make my 2 molar solution. That's what we're going to do next. No, not even my glasses case has the right periodic table of elements on it, still just atomic number. However, we're never far away from another set of periodic tables in my house, and so here's one that's got the necessary bits and pieces in it. So let's find sodium. Our chemical compound, don't forget, is sodium hydroxide, NaOH. So let's look for Na. It's in group 1. There it is, and its mass, which is always the big number out of the 2 that you see. So there's the atomic number, there's the mass number. Its mass is 23. So before we forget, let's write that down. Here's a convenient blank page. Sodium, 23. And hydroxide, so there's an oxygen in there. Where's oxygen? Oh, there it is. Big number, 16. Oxygen, 16. And hydrogen, as if we needed to go and find it, is 1. But if you want a proof, let's find hydrogen. There it is. Both the atomic number and the mass number are the same, 1. So, it's now a question of working out the relative formula mass. Here's our triangle, mass in grams, moles, mR. I want to make a 2 mole solution, okay? So I know how many moles I want, and I can work out the formula mass now. 23 plus 16 plus 1 equals 40. There we are. Now, I want a 2 moles solution. So, if I factor that into my triangle here, okay, mass is my unknown. I've got 2 moles, and moles times formula mass tells me the mass in grams that I want. So even I can do that in my head. 2 times 40 equals 80 grams. So I need to weigh out 80 grams of sodium hydroxide pellets in order to get my solution. Okay, so kitchen scales, and I've got a jug which holds a litre or 1,000 millilitres, or to use the GCSE terminology, 1 decimetre cubed, which is a litre, 1,000 centimetres cubed. It is our kitchen one, and I will be rinsing it out many times before it's ever used for anything that might be even touching food after I've done this. To be careful. Turn on my scales. My scale should be clever enough to set that as 0. And I need 80 grams. So, my sodium hydroxide pellets, in we go. Just nice and careful. Okay, so there we go. Already that's 41 grams, so that's just over a mole in there. 6.02 times 10 to the 23 particles of sodium hydroxide. 78. 79, 80, there we go. So, 2 moles of sodium hydroxide, and I want to make a solution
That is 2 moles per decimetre cubed, or in slightly older terminology, 2 moles per litre. So I'm going to make it up to my litre mark. I don't know if my camera person can find the litre mark on there. So now this is a very, very, very exothermic reaction. So actually what you need to do is add about half of your water, because what happens is that this then heats up very strongly, which of course means that the water expands. So if we were doing this and we needed to be very, very, very careful indeed as to the exact concentration, we'd get it wrong if we made it up to a litre directly without allowing it to cool down. So that's what we're going to do. I'm just going to let that happen. Even through Pyrex, that's starting to feel warm even now, so I'm just going to leave it for a little bit and come back when things have cooled down, which might be a good half an hour or so. Okay, so in fact we left it about an hour, and that's cooler now, although I'm not going to touch the inside of it. Most of it's dissolved, although you can see it is still a little bit cloudy, and I'm just making it up to 1 litre. This probably isn't the most accurate of jugs, but it's the most accurate that I've got. And there we go. We now have a solution of 2 moles per decimetre cubed concentration of sodium hydroxide. Now to leave it to work its magic, and then I'll pour it onto my baking tray. See you in a minute. Okay, so my sodium hydroxide is made, my solution. Most of it is going to go into my manky tin to help get rid of all of that horribleness, which will need a little while to do. So we'll come back and we'll have a look at that in another hour or so. So that's made most of it, but I've got just over half a litre left, and I don't want to waste it, so I've got this bottle here. I'm going to pour the rest in. A little swirl. And there we go. That is ready for next time I accidentally make a mess of my baking trays. I will now put that somewhere far away from any water, far away from any questing hands that might accidentally pick it up. I've written danger, sodium hydroxide, 2 moles per decimetre cubed. It's very important that I write the concentration on so we know that it's something that we need to be a bit more cautious of. And we'll come back and we'll see if it's worked its magic in a little bit. So, after a few scrubs in the sodium chloride hydroxide solution and many, many rinses with good clean water to take all the residue away, we have a nice clean tin ready for whatever other culinary adventures I want to throw at it. Proof, if anyone needed, that chemists have always got the right solutions. Speaking of which, Merry Christmas.